Hello, I'm Christina. Today we are going to learn how to find the determinant of a matrix. The determinant is a number associated with square matrices. Depending on the size of the matrix, there are different methods to find the determinant. Today we will learn 3 of them. Let's take a look.
When a matrix is 2 by 2, the determinant is equal to the product of the elements of its main diagonal minus the product of the elements of its secondary diagonal. Let's calculate the determinant of the following matrix. Since it is a 2 by 2 matrix, then the determinant of the matrix is equal to 4 times 0, which are the elements of its main diagonal, minus 1 times 6, which are the elements of its secondary diagonal. So the determinant is equal to 0 minus 6 equal to minus 6. Well, when we have larger matrices, 3 by 3, 4 by 4, 5 by 5, we have a general method called cofactor expansion. To work with this method, we first need to understand the concept of a minor. The minor ij is the determinant of the matrix obtained by deleting row I and column j. And it is symbolized as minor ej. Cofactor. The cofactor ij is equal to negative 1 raised to the power of I plus j times the minor ij. Let's calculate the cofactors of the second column. Cofactor 1. 2 is equal to negative 1 raised to the power of 1 plus 2 times the minor 1. 2. So, negative 1 to the power of 3, the minor 1. 2. We eliminate row 1, column 2. We are left with the elements 3, negative 8, 9. So we have negative 1 cubed, negative 1 times 3 times 9, 27 minus negative 8 times 1, negative 8. We add them and get negative 35. Let's move on to the cofactor. It is equal to negative 1 raised to the power of 2 plus 2 times the minor 2, 2. We then have negative 1 raised to the power of 4, minor 2, 2, and we reduce row 2, column 2. We are left with the elements 4, negative 2, negative 8, 9. We then have negative 1 to the power of 4, 1, which multiplies 4 by 9, 36, minus negative 8 by negative, the hostile, equals 20 cofactor 2, 2. Now, cofactor 3, 2 is equal to negative 1 raised to the power of 3 plus 2 times the minor 3, 2. This is equal to negative 1 raised to the power of 5 times the minor 3, 2. I eliminate the row. 3, column 2. We are left with the elements negative 2, 1. So, negative 1 to the power of 5, negative 1, which multiplies 4 by 1, 4 minus 3 times 2, negative 6. And this gives us negative 10. Now, how to calculate the determinant of a matrix by cofactor expansion? I select any row or column. For example, I select row 1 with the elements 4, 7, minus 2. Then, the determinant of A will be equal to 4 times its cofactor, as it is located in the row on column 1. It would then be 4 times the cofactor, 1, 1, plus the second element of the row, 7, then 7 times its cofactor. Where is it located? Say, in row 1 to column 2. Then we have plus 7 times the cofactor, 1, 2. Plus, what is the third element of the row? Minus pondo. And where is it located? Minus do. In row 1 on column 3. Then it becomes minus 2 times the cofactor, 1, 3. With this formula, I can calculate the determinant of matrix A, but I can also choose a column and I will arrive at the same result. So, if for example, I now select the second column, column number 2, the determinant of A will be equal to 7 times the cofactor 1, 2, which is the position where it is located, 7, minus 5 times the cofactor 2, 2, which is where minus 5 is located, plus 6 times the cofactor 3, 2, which is where it is located. So, let's do the exercise and calculate the determinant of this matrix by the expansion of cofactors. Let's do it with the second column. That is, the determinant of A is equal to 7 times the cofactor 1, 2, minus 5 times the cofactor 2, 2, plus 6 times the cofactor 3, 2. So let's calculate the determinant of A. The determinant of matrix A is equal to 7 times the cofactor 1, 2, minus 35, minus 5 times the cofactor 2, 2, which is 20 plus 6 times the cofactor 3, 2, which is minus 10. So the determinant of A is equal to minus 245, minus 100, minus 60. And in total, it gives us minus 400. The determinant of matrix A is, we place columns 1, 2, and 3 of matrix A and duplicate the first and second columns. And now we are going to multiply in the direction of the diagonals. Let's first multiply the main diagonals. So we have 4 times minus 5 times 9 minus 180 plus second diagonal 7 times 1 times minus 8 minus 56 plus minus 2 times 3 times 6 minus 36. And from these products of the main diagonals, we are going to subtract the sum of the products of the secondary diagonals. So we multiply minus 8 times minus 5 times minus 2 minus 80 plus 6 times 1 times 4, 24 plus 9 times 3 times 7, 189. We calculate the sums within the brackets. Here we get minus 272 minus second bracket 133, and we get minus 405. The determinant of matrix A is equal to minus 4005. Notice that it is the same value that we obtain using the cofactor expansion method, because the determinant is a unique real number associated with a square matrix.